Welcome back, Python family, to the Python Made Easy series. This is going to be a phenomenal session. If you only have time to review one presentation or blog or site on os.walk, let this be the one. This presentation is jam-packed with explanation and example. I believe you will walk away with a very good understanding of this very powerful tool. Here we go. What is the os.walk function? os.walk is part of Python's OS built-in module. The OS module, as you might recall if you've been following along in this series, consists of operating system interfaces. It gives you a portable way of using OS-dependent functionality in your Python code. So it's independent of the OS that we're running our Python code on. os.walk allows us to generate file names in a directory tree by what they call walking the tree. So we're able to get at folders and their subfolders and the files in every level. For each directory in the tree, a tuple of 3 elements is returned. dir path, this is the path to the current directory. Dir names, these are the subdirectories in the current directory, or at dir path. And file names, this is a list of the names of the non-directory files in the current directory, or for dir path. Okay, so let's see what this looks like and what os.walk is all about. On the left-hand side, I have my code. On the right-hand side, I have a directory structure that we're going to be acting upon using os.walk. So let's start from the top. My_dir is a given directory path that you see exposed on the right-hand side. It stands for users/my_tests. So the first thing I want to do is just print out start print. So we know where we're starting and we know where we're ending. I'll print out end print at the end. So for root dir path, subdirs, and files in os.walk against this directory my_dir. So this is this tuple of 3 elements that we're setting up, right? Root dir path is the root of a given directory. Subdirs would be the subdirectories inside of those, and files would be the files inside of the given root path. Now, the first thing I want to do is I want to be able to show you what the output looks like for each of these. We print the root, we print the subdirectories, and we print the files. I'll end each segment or iteration with 25 asterisks, and then I'll print end. Okay, and we'll go to the next page and we'll see exactly how this looks and how it compares to what we're seeing in our directory structure on the right-hand side of the page. Okay, and here's the output. So at every level, we have a root directory path. So that's the first element of the 3 tuple. So it's users mytest first, and you see how that corresponds to our directory structure right here. And that prints out subdirectories, pycache, and testing1, which is at that level, right? That sits in that directory, and it prints out all the files. You can see them all there. Then we go to the next level, which is the pycache folder level, and that has no subdirectories, and it has 2 files, and it prints them out. Then we go to the next level, and that's testing1, and that has 1 subdirectory, testing2, and 1 file. Then we go to the next file, which is testing2, right? And that sits in the base of testing1. And that has 2 subdirectories, testing3 and testing2a, and it has files, and so it goes until we've gone through the whole, until we've walked, right? And until we have walked the entire directory structure from the top to the bottom. And from here until the end of this class, we are going to show you just more and more useful examples, expose you to different techniques, and become more and more complex as we go. Okay, so this one is walking the directory tree and printing out only files. So you'll start to see some very common techniques being used here and common syntax. So let's go through this first. os.walk traverses a directory recursively, and for each directory it generates a tuples containing the directory path, any immediate subfolders of that path, and a list of the name of any files in the directory, which is exactly what we saw in just the previous 2 slides when we went through this. And recursive in this context, or a recursive expression, is a sequence of instructions that loops back to the beginning of itself until it detects that some condition has been satisfied, like reaching the end of the things that we need to process. Okay, so with that, we'll look at this code on the upper left-hand side. For dir sub files, like I can call those variables anything, but it's what they represent and the positions that they're seen as it relates to os.walk that matters, right? So here I'm calling them something different, dir sub files, just to be curt. In os.walk, I'm using my same directory, my_dir. The first thing I'll do is print the directory, prints out each directory, sub. Now I'm using list comprehension, n for n in sub, instead of doing a for loop. Okay, and then contents, I'm concatenating the sub to the file name. And then I will sort. I'll use the sort method, so contents.sort. And then I do a loop on the individual elements of that sort. So for f in contents, if os.path is file, that's how I'm acting conditionally here. I don't want the directories, I only want the file. Print, and I'll tab in just to make it easy to see, just the files, and then I print just for space between each iteration, and you see what happens here. I get only the files at each level. So I print out the parent dir, and then I get just the files in each file that it sees. Okay, does that make sense? I hope it makes sense. If it doesn't, leave me notes. I'll try to get back to you as soon as I can with any clarification that you may need. Now, on this page, we looked at just printing out the files in the previous slide. Now we're going to do just the subfolders, and it's very much the same. In fact, the first 4 lines of the code is the same. For dir sub files in os.walk mydir, print the directory. Then we use our list comprehension again. N for n in sub. We're just iterating over all those different subdirectories. We'll sort on the sub. And then we do our printout for f, the individual subdirectory in sub, print, and then we'll tab over just the subs, and they print out, and you see as they do. So these are just the subdirectories in that directory structure that we've been using. Okay, so not the files this time, just the subdirectories. And you see down at the bottom, the testing 3 and testing 2a don't have any subdirectories. Okay, so I'll fly in this directory structure again, and let's just verify that. Okay, 3, it has files. 2a, it has files, no subdirectories. So aren't the files printing again? Ah, because we're only printing subdirectories, right? So all is well. The objective of this snippet of code is to count all the elements in our directories and subdirectories. We don't care if they're directories or files in this particular case. So we're going against users test, a different directory. It's a little bit smaller to just make some of these examples easier to understand and see. So you see that on the right-hand side. We set a counter. Count_file. It's an integer. It's equal to 0 to start. Then we go into our for loop for os.walk. Path, sub, and file names. In os.walk, we point it to that directory dir1. We have our list comprehension on the sub, n for n in sub. So we iterate over all the subs. Content equals, and then we'll add together the subdirectories and the files. And we'll use that in our next for loop, so we can iterate against all its elements and add them together and add the sub to our counter, count_file. We increment by 1 right here. And then when it's all done, we print it out and we see that we have 10 elements. But if you were to count all the files and folders on the right-hand side, say, wait a minute, I think I see 9, you'd be right, because .ds_store is hidden in this particular view that I have for you here. So it is 10, all is well. Now, if you're working on these examples right alongside me, you might have recognized that Python puts some weird files and folders in a repository, and you may want to do without those. So for instance, we have these dunder folders, or these folders that have dunders or double underscores at the beginning and the end of their names. So in this particular exercise, I get rid of those. I don't want to see those. So if not path.ends with, in quotes, underbar, then print the path. And you see it does a very great job of quickly getting rid of those, so they're no longer in my view. Now, staying with the theme of excluding some of our subdirectories, here what I did was I have a few folders in this test parent folder that start with numbers, 1 dot, 2 dot, 3 dot. You see them here up at the top, 1.test, 2.test, 3.test. And I decide I don't want those. I don't want anything that starts with the number and then has a dot. So what I do in this for loop for dir in dirs, if not dir1 equals 1. So I'm saying if in its second position in zero-based indexing, that would be the second position for the file name. If it doesn't have a dot there, then give me that in my return. So that's an easy way, a very easy way, a few lines of code to be able to exclude those folders that you don't want. And in my case, in its second position where I have a dot. Remember, these are just strings, so we can apply slicing and indexing. Any methods and attributes that we can use against a string, we can use here. So if you're ever confused about that, you can go into Python Interactive. You could either do a dir against str, or you could create a string. String 1 equals foo, in quotes, and then do a dir against string 1, and it'll bring you back all those methods and all those attributes that you can use against the string. I encourage you to play with those. See what you have at your disposal, because when you need that tool, you can just pull it out of the toolbox and use it. We're going to use a sister method here to rename directories based on conditions. We're going to use os.rename. And os.rename has a source component and a destination component. So let's see what the directory structure looked like before. Before is in the upper left-hand corner. After is in the lower left-hand corner. We're going to be focused in on the files that end with .test. Okay, and we see that right here. Let's go through the code top to bottom. So for root dirs files in os.walk dir1. Dir1 is the directory we're feeding it, and that's users/test. For D and dirs, we're focused in on the subdirectory level. If d.ends with .test, now you see that we have many, in fact, almost every single file and folder has the word test in it, including the parent. But we only want, in our population of things we rename, are those folders, those subdirectories that end with .test. So you know right away that will just be the first three here, 1.test, 2.test, 3.test. So then the print D, we don't need that. That was just for my purposes for testing. That doesn't help this to run at all. os.rename source is root.os.sep.d. That's what we have now. And what we have to do to make this work is we have to give it the full path. If we don't give it the full path, os.rename will not work. And os.separ, the separator, is the character used by an operating system to separate the path name components. So for Linux-based system, Mac-based systems, it'll be the /, and for Windows, it'll be /. So we give it root.os.sep plus D, which is the actual name of that subdirectory. And again, it'll only pull those if it ends with .test. And then the destination will be very similar, root.os.sep plus D plus a period plus the word new. So you see that we were very successful in this because those three folders here have now become 1.test.new, 2.test.new, and 3.test.new. So mission accomplished, we're good. So we're going to do the very same thing here, but instead of using the os.rename, we're going to use the os.replace. Other than that, everything is exactly the same. I just wanted you to know that you can absolutely do this with two different functions or two different methods, both from the OS module in Python. One thing here is I'm changing the destination. So instead of 1.test.new, I want it to be new in the front of the word and then the number 1 in the end. So look and see what I did here. For the destination, root.os.sep as always. Then I go right to the word new, and then I'll add D, the file name. However, I'm using a slice, and I'm using :-5. So from the start of the string, D in other words, our existing file, up to, but not including, the -5 index from the right side. So what that does is that'll give me the number, but it doesn't give me anything to the right of that. So it doesn't give me the period test. So I'm left with, for 1.test, I'm new 1. For 2.test, I'm new 2. For 3.test, I'm new 3. Okay, that's back to just, again, whatever we can do to a string, we're able to do to the names of these files and directories. So it's kind of neat. In this example, we'll print out all files in all directories and subdirectories except for those files that end in .py. So no love for Python files in this example. So for path subdirs files in os.walk mydir, for file and files, if not file.end with .py, and also I'm sick of those, the hidden file that starts with the period, so and not, compound if statement, and not file that starts with period, file path equals os.path.join. So I'm going to join the path to the file using os.path.join. and then I'll print out the file, and you see what we get. We indeed do not get any files that start with period, and we get no Python files. All right, here I want to get the size of each file and the last modified date. So I'm actually going to make use of some methods from the time built-in module in Python as well here, just for a little section of this code. I'll walk you through it. So for path sub-dirs files in os.walk mydir, for files and files, if not file.ends with pi and doesn't start with the period and doesn't end with .pyc, another type of Python file, I'm excluding those as well. File underscore path equals os.path.join path and file. So we saw that in the previous example, joining the path, intelligently joining the path to the file name. File size equals get size. So the os.path.get size we're using here. We haven't seen that before. And we're passing that the file path, the join between that path statement and the actual file, each file that we iterate over. And all os.path.getSize does is return the size in bytes of the path that it's presented with. Then info equals os.stat, and we're passing that file path. So we haven't seen the os.stat. os.stat, again from the os module, gets the status of a file or a file descriptor. And an attribute of os.stat we're going to use is st_m_time, and that tells us when the file was last modified. So print file name, and then we use string formatting 0, 1, and 2. We're just justifying to the left here in a field of 65 for the first element, and justifying to the left in a field of 10 for the second, and nothing for the third. File path first, file size, and here's where I convert, because remember, st.mtime presents the time it was last modified in seconds. So we want to convert that to something human readable, or that we can understand, unless you're a wizard for seconds and converting that. Time.ctime, and then we pass it that info, right? Because info equals os.stat.filePath, and now we can extract different attributes. So we're going to extract that st.mtime, the time it was last modified, and just convert that into what you see down here, Friday, February 8th at 15:59, etc. in military time. Our objective of the code here is to get the total size of a given directory. And our directory in this case is one that we've used before, users/mytest. And you see it down here, my_tests, 41 kilobytes. So we have a function that we wrote this time. Def get size, we pass it one parameter dir. Size equals 0, and we're going to use size as we iterate through this to add to that as we traverse through and walk through all of these files and subdirectories to be able to add the file size to each of the previous to get our total size, our composite size. So for path sub file names in os.walk dir, we pass it dir. For f in file names, file_path, os.path.join, the path plus the file. And then we do size, right? We add to size, which is now 0 for the first time. To that, we add size plus os.path.getSize, file_path name. So get size that we just saw, the join between the path and the file directory, we're adding that each time we loop through this to this integer size, right? And then we return size. And here is just our caller, dir_size equals get_size, which is our function. The attribute we're passing is my_dir, which equals users/my_tests. And then we print out the total dir size, bringing back that caller, which is dir_size. And that prints out 40,650 bytes, which roughly translates into 41 kilobytes. So this piece of code is almost identical to the one we just saw. The only difference here is we wrote a function to convert to megabytes so that we're able to see this better as these sizes might get larger for us. Certainly nobody's tracking bytes, right? If you are, you have a very small shop. So we have a function called con_mb. It takes a value, and con_mb for me stands for convert to megabytes. Then we have the figure that we will divide by to turn a byte into megabytes. So we round our value, whatever's passed in for our value, divided by that number, and we round out to 2 places. Then our code is exactly the same here in our get_size function. The only difference is I have a variable con_size equals con_mb size. So we call that function right there. That's our caller. We pass it size, which is that iteration of that empty integer, right? That every time we go around, we're going to add path and file to that. So we get each successive size of the file, and we just keep adding it there to get to our total size. Then we return con size instead here, which is our caller, and that gives us our total megabytes instead of total bytes. And here we want to get the size of directories and the individual files in directories and subdirectories. So this code will start out looking very similar, and let's see how it's different. We start with a print, then we have our for root dir path for our root, subdirs for our subdirectories, and files in os.walk, my_dir. We can go top down with os.walk or bottom up. So I decided to go top down. Here is true, which is the default. If root_dir.path.ends with, so I want to get rid of those files that start with the double underscore, I just say continue. Else size equals sum. Now we're summing the get size of the join root dir path and name for name in file. So what is that? That is a generator. So there's different ways to do these things, but that's how we're getting the size there. Then we print root directory, concatenation to root dir path, so the full path of the root, and then directory size, and we pass it size. And that's how we spit out right here the size of the directory, 27106, 6148. I'll mention that this is just partial output because I ran this against a fairly large directory, so I wanted to make sure you knew that. You're not seeing the whole thing. So then for files and files need to be in a string form to be able to join them. So I have to be able to iterate over those. Otherwise, it'll pass me an error. FP, again, is our famous os.path.join, the root plus the file name. And then I tab over my print statement with some print formatting that we've seen before. And I format FP, which is what? The concatenation of the root path plus the file name. And then I get size of FP. So you see I do two things here, which is pretty neat. I get the directory size, and then I'm able to get the individual sizes all together underneath that. So if you were to add up those individual ones, those individual files, you'd see that it should equal our total directory size. And as I always like to do, I like to save the most involved or complex example for the very last code snippet in our class here. So in this one, we're going to build on everything we've done. We're going to sort on file size in reverse order this time, based on conditions, and one of those conditions will be give me nothing under 3 megabytes. So my dir this time is a new path. It's actually the path where I keep my directories for upload for this whole series for GitHub, for uploading my PowerPoint decks here and the associated code. Then we have an empty list. List1 equals empty list. Then I have a print statement just for formatting, and then I do my usual for root dir path subdirs and file in os.walk, my_dir2 top down equals true, which I don't need in there. For f in files, so files need to be in a string just like before to be able to join them, which I will do in just a minute. If not f dot ends with, so if it doesn't end with double underscore and it doesn't start with a period, I want those, so act on those. So fp equals the os.path.join, root dir path and f, so we're joining those together as we have so many times. So far so good. So I have my megabytes here, which I don't need because I'm actually calling the function later on. I should have cleaned that up in the code. My apologies. You don't need that here. Size equals os path.getSize fp. Then I have my variable con_size, which will do the conversion. So con_size equals con megabytes size, and we pass that the size of os.path.getSize fp, which is the join between the root and the file. And then if fp not in list 1 and con size is greater than 3. So what am I doing here? I don't want duplicates in my list, so I say, okay, if you're not already in the list and your size indeed is greater than 3 megabytes, then append to the list a tuple. This time I don't want one value, I want two. So I want fp, which is the name, and con size, which is the size. Then I do a sort using the sort function. Key lambda, I use a lambda expression. S1 in this case is second position from the list 1, and that is the size, right? Because 0 position would be fp, and that would be the name. I don't want to sort on the name, I want to sort on size, so not S0, but S1. Reverse equals true. Why am I doing that? Because I want to expose those items that are the largest first, right? Those are the most important that will need most of our attention. So I'll let the smaller ones go down to the bottom of the list and then simply iterate over my list. For L in list, I do file name L0, right? Because it's a tuple, so I can extract that first part of it. So 0 is what? It's the name. And then I have to cast the integer to a string to concatenate the megabytes. So it's string L1, 1 is the size, plus megabytes. And it prints out this tidy list based on our conditions and our exclusions of the largest files in our directory down to the smallest, and nothing under 3 meg. Pretty cool, huh? Okay, Python family, thanks for watching till the end. If this class has helped you, consider helping me to continue to bring these classes to you and others. Helping's easy. Just do the following. First, subscribe to this Yogi Coder YouTube channel. Next, like this video and leave whatever comments and or questions you feel moved to. Finally, share this video on any and all social media platforms with your friends and colleagues. And as always, this presentation and its associated code will always be stored up on GitHub at the link in the section below. That's it for now. See you in the next one.